Okay, here we go. I'm going to go over a lot of these problems. I'm going to skip around because, quite frankly, this entire unit's it's redundant, so you get the idea of what a graph looks like and how to read it. So, with that being said, here we go. Let's do the first two. They take up an entire page, so that just makes this graph all the smaller. So again, hopefully you've checked the reading material, as it says at the very top. Read into the reading material first. All right, first thing I want to look at is this is a distance versus time graph. Distance, time, right? So it's not velocity versus time, so that makes a big difference, right? So in distance versus time, that means where do they start at, and then how far do they go within a given time, right? So looking at this first graph, before we even read the question, they started, two people ran, two runners. This one started at point 0, we'll call it the 0-yard line, and they ended at the 20-yard line, right? Because this is the distance right here, which means they went 20 yards in 4 seconds because it ended in 4 seconds, right? And you remember, velocity is just distance over time. So we can figure out velocity from this graph. I want to note something. In a distance versus time graph, if the line is slanted, that doesn't mean they were accelerating. Okay? Because, look, that's consistent. They consistently changed their position over a given period of time. That means they were a steady pace. If it was a velocity versus time graph, that would have meant accelerating. But remember, because it's distance versus time, that just means steady pace. The thing to note is, the sharper the line, the faster they went. Because you can determine velocity from this, right? Because it's distance over time, which means the distance this person ran was 20 yards, and the time was 4 seconds, which means 20 divided by 4, this person went 5 yards a second, right? Pretty fast, right? And then this person went 10 to 20. That's only 10 yards, right? In 4 seconds. So distance over time equals 2.5 yards a second. All right, I think that's 2.5, yeah. So with that being said, let's look at the question. Which of the following graphs shows that one of the runners started 10 yards further ahead of the other? Wow, that's actually way easy. Just started 10 yards further ahead. 10 only. Well, let's start from the wrong one so we can actually learn something. Right, let's start from this one. Looks like they both started from the 0-yard line. That was their distance. So it ain't D. Let's look at this one. Well, this person started at the 0. This person started at the 20, so they were 20 yards apart. We need 10. All right, so it ain't that one. That's too far. Then look at this one. Oh, I see the number 10, but that doesn't mean it's right. They both started at the 10. So that means they started 0 yards apart, right? Because they're both on the same one, right? This one started 0, one started 10. They were 10 yards apart. So that's why this first one is A. That makes sense, all right? So this was distance versus time. All right, let's go to the next page. Rewind if you guys got questions. I'm going to go through most of this. Oh, this is so far apart. All right, so I'm just going to read this question. In which of the following graphs below are both runners moving at the same speed? Remember, the slant, you can calculate their speed because speed is velocity equals distance divided by time, but you can also look at the slant. If the slants are the same, then that means they run at the same speed, right? If they're clearly different, then they're going a different speed. Because that means, so for instance, this one, if we're both timing how far we can run in 4 seconds, and I run 10 yards in 4 seconds, and you run 20 yards in 4 seconds, well, you're clearly faster, right? You doubled my speed. And looking at this one, just because we started at a different yard line doesn't mean we can't be the same speed. Now, these are two different speeds, but nevertheless, I started at the 0, and I ran 30 yards in 4 seconds. So that's a total of 30 yards. This guy started at the 10. He started 10 yards ahead of me, but we only care how far he went, not where he started. He went 10 yards in 4 seconds. So this one was clearly faster. But remember, we want same speed, right? So, I mean, you don't really have to look too far ahead for this one. This guy was faster than this guy. They started at different yard lines, but they're going the exact same speed. Because remember, they both covered 10 yards, right? From here to here, or from here to here. 10 yards in 4 seconds. So that means same speed, right? So that one's a piece of cake. It's D. If you guys aren't getting this, no worries. You will. It's not very hard. Repetition, you'll get it. Let's keep moving. Okay, more distance versus time stuff. Oh my gosh. It's so scary. Here we go. It's scary. Alright. Distance versus time graph below represents the motion of a car. Ooh, let's zoom this out. Shall we zoom this out? Yeah, we got to get back. Let's bring it back a little bit. It's been brought back. Alright, here we go. So remember, this is distance versus time, which means it's about position. On the y-axis, it's not about speed, it's position, right? So let's look at all of these. Car is stopped. Car is traveling at a constant speed, meaning it's not acceleration. So not accelerating, no acceleration. The speed of the car is decreasing. That means it is accelerating downward. The car is coming back. Okay, so that means its distance is going downward, right? So let's look at this. Let's look at this one. When I first look at this one, especially when I'm helping out students that are just coming into this unit, they see this graph and they automatically say, well, bam, that one's speeding up. Easy. Okay, well, it's actually not speeding up, and I'm going to tell you why. Remember, this is distance versus time. This means it's a very smooth line, right? So this means its distance has steadily changed over a period of time. So for instance, if you're in a car and you're going 40 miles an hour and you have it on cruise control, right? So you're going 40 miles an hour cruise control. Your distance will steadily change over a given period of time, which means you're at a constant speed, right? So this one is actually 2. Alright, so let's look at this one, C. You are in a car at position X, we'll say, right? And over a given period of time, your distance, your position does not change. So if I'm like, hey, I'm going to time how fast it takes you to run 100 yards, and I say go, and I hit the timer, and you just stand there, and your position never changes, and then I stop it. Well, if your distance is 0 over time X, well, it doesn't matter because your distance is 0. You have no speed, right? Your car is stopped. So this is actually 1. So this is my, yeah, that should have been A, and this is C, right? Because your distance never changed, your position didn't change, so your car's 0. All right. Let's look at this one. Your distance is changing pretty sharply, but as time goes by, it stops changing as much. So let's think about this. Your distance changes quite a bit, pretty rapidly, right? And then as time goes by, your distance, your ground covered, reduces until your position barely changes over a long period of time. You know what this tells me? This tells me that the speed is decreasing. Because your distance changes rapidly and then less rapidly and then almost nothing at all, right? And then we have one more, B. So think of this as your starting point. So your distance changes back to your starting point over time. So that's what this slanted line means. You're coming back, right? So that's B. So that was pretty easy, right? That ain't bad. Remember, distance versus time, a little different, but if you think about it, it's not bad. All right, let's go to the next page. Okay, now this is where most people are comfortable because now we're doing speed versus time, velocity versus time, right?